The phenomenon where Earth's moon is slowly moving away from the Earth is a well-documented process known as lunar recession. The moon is drifting away from Earth at an average rate of about 1.5 inches, 3.8 centimeters, per year. While this may seem like a small amount, over millions and billions of years, this could have significant effects on Earth's system, particularly on tidal forces and the length of a day. Reasons for lunar recession. The primary reason the moon is moving away from Earth is due to the interaction between Earth's tidal forces and the moon's gravitational pull. This process is driven by a phenomenon called tidal friction. Tidal friction. Earth's oceans are constantly pulled by the gravitational force of the moon, causing tides, high tides and low tides. The Earth's rotation causes the tidal bulge, the area of the ocean affected by the moon's gravity, to be slightly ahead of the moon's position in its orbit. The gravitational attraction between this tidal bulge and the moon actually pulls the moon slightly forward in its orbit, giving the moon additional energy. This additional energy causes the moon to gradually move to a higher orbit away from Earth. Angular momentum. The tidal friction also slows down Earth's rotation. As Earth's rotation slows, some of that rotational energy is transferred to the moon, causing it to spiral outward. As Earth loses rotational speed, the moon gains energy and moves away from Earth. Effects of the moon's recession. Longer days. As the moon moves farther away, Earth's rotation slows down. In the past, the Earth's day was much shorter. Around 600 million years ago, a day on Earth was only about 21 hours long. Over time, this lengthens the day, and scientists believe that, in the distant future, Earth's day could be much longer than the current 24-hour cycle. It's estimated that in 100 million years, a day could increase by about 2.3 milliseconds. Changes to tides. As the moon moves farther away, its gravitational influence weakens. This would lead to less pronounced tidal effects on Earth. While tides would still exist, they would be less extreme. The moon's role in stabilizing Earth's axial tilt and its climate might also diminish over time. The moon's escape. If this process continued uninterrupted for billions of years, the moon could eventually reach a point where it would be in a stable orbit and no longer be moving away from Earth. However, this scenario would take a long time, and the Earth-Moon system could be affected by other cosmic events, e.g., the expansion of the Sun in the distant future. There's also the possibility that eventually the Earth and Moon could reach a gravitational equilibrium in which the Earth's rotation and the Moon's orbit are synchronized. This would mean that one side of Earth would always face the Moon, similar to how the Moon currently only shows one face to Earth. Theoretical long-term effects. In about 5 billion years, the Sun is expected to enter a red giant phase, expanding outward and possibly engulfing Earth. Before that happens, however, Earth and the Moon will have undergone drastic changes due to tidal interactions. By that point, the Moon might be much farther away, and Earth's rotation will have slowed significantly. In the far future, the Moon